Hi, and thanks for having me today at the Semaphore conference. I'm going to talk to you a little bit about what we do at ProGlove, the company I work for, and especially what we do around making wearable barcode scanners. My name is Patrick Blitz, and besides making barcode scanners, I like coding and working with code. So let's see how this applies us. I'm going to talk today about going full silo, which is what we call our architecture. Well, at least I call it. I guess the rest of the team doesn't like the term so much, and how it makes dev simplicity in a serverless backend world. But first, let me take a step back and talk a little bit about what we do as a company. So, as I said, we make wearable barcode scanners. These are little, tiny 60-gram devices that sit on the back of your hand, and they have, an image unit in there, which is a barcode scanner. Actually, it takes pictures. It gets a lot of, temperature data and other data. It also is basically a Fitbit or, a smartwatch with, an IMU, all of that data. And what do we do with that data? Classically, well, we translate the barcode into a string and literally type it in. Obviously via software, but in the end it's typed into another system. So very low-tech approach to processing the data. What can we do with all of the rest of the data? We obviously thought, hey, let's build a device management analytics SaaS offering, software as a service offering, to make use of that and give our customers access to all of that additional data. What do I mean with that? Well, we have the secondary data streams from the shop floor. We have the barcodes, the pictures, the MU data, all of the movement data, a lot of things. Ingest that data, manage the connectivity devices, which I'll come to what that is in a second, manage the scanners. Obviously they can get lost fairly quickly. I can put them in a pocket and just walk out. That's, that's €1,000 somewhere. I have to find it. We can detect workflows, we can compare, we can optimize usage. That's the final goal. That's what we set out to do. But there are some big buts on this. One is we're doing this for what you see on the other side of the slides. We're doing this for large multinational corporations. BMW or Volkswagen, I'm not sure, is a major customer. Both of them are. Nearly all automotives are at this point, but also a lot of, logistics companies will be. How do we make sure that, stay safe, stay in a sensible environment without having the dev team of a BMW or an Amazon or whatnot? Like, we're small. In the end, we're about 300 people. When we started out on this journey, we were half that. We were like 150. We knew that we needed to build a multi-tenant approach. So we needed to have something that allows multiple customers to use the system. We knew that data security, privacy will be very, very important. We are accessing production or primary data from that customer in the terms of the logistics company. We were really, really small as a team when we started out, with 3 developers. Now we're somewhere around 10, still not humongous for the backend part. Serverless seemed like a very good fit for us. We knew that we needed a free tier. Obviously, it's going to be a SaaS software that somehow always needs a free tier or at least a free trial or something like that. So we decided to go all in on serverless, have as much isolation as we can, tenant isolation, I'll come to that in a second, and also trust our cloud provider to have much better security than we have. And with those tenants set, let's have a look at our architecture. Well, actually, not quite. Let's quickly talk about tenant isolation. This is a very important term in building, SaaS software. So let me quickly go in there. if you have multiple customers, multiple entities using your infrastructure, your software, you need to separate them out somehow. Most often you don't want all of the customers don't want to share their data, right? They want to keep their data separate. So you want to do some kind of tenant isolation. And there are two major ideas here. One is you use pooled infrastructure. You have one load balancer or load balancer farm, one application server farm, and one database cluster or whatnot. And then in that database, in that table, you'll have tenant IDs next to your data, so you can identify which data belongs to which customer, or tenant as they are called. The other approach, put another box next to it. Just have one load balancer, one application server, one database per customer, siloed. The approach, we have one of each and just separate out the data and the application logic. It's called pooled. One is logic-based tenant isolation, one is infrastructure-based tenant isolation. In a normal cloud environment, you gravitate towards a pool architecture because that's kind of what you do oftentimes. In the olden days, when you would actually install boxes at a customer, hardware, or sell software that would run on hardware, you'd be very often in a siloed approach. We decided, and actually AWS decided, like this is a pattern that they offer, is multi-account, where you actually lean towards the siloed approach. And that's what we did, and we took it to the max. So we have our architecture. Let me quickly go over that. This is what we are currently using. We have, the devices on the shop floor. We connect them via Bluetooth to either an Android phone, iPhone also, but very little customers use that, or a gateway, which is a small basically Bluetooth device connected to a computer. And that then also connects as a secondary data stream into our SaaS offering, to our cloud, as you often call it, right? And there we have an IoT broker, an event bus, about 30 microservices, 39 microservices, 40 microservices that use the data, and one API. This is all built on Python and as much, managed services as we can to make it easier for us to handle and reduce the load on the team. So we'd use IoT Core, Event Bridge, Lambda, DynamoDB as kind of the main drivers on that, or API Gateway on the API side. And then we have a single web frontend. But the stuff in the middle, from the IoT broker to the API, we deploy once per customer in a separate AWS account. So for the next customer that comes along, we deploy the next AWS account, and the next AWS account, and the next AWS account. And the full architecture in each one of those accounts. So we end up with about 3,500 AWS accounts that run the full architecture. Everything you saw in that small picture is going to be included in each one of those 3,500 accounts, more than can fit on that slide. This brought us some really cool things and also some downside. I'll come to that in a second, and also I'll tell you what that does to our CI system, because that gets very interesting. We have the highest amount of tenant isolation you can think about. There is no risk as a developer that you access data from the wrong tenant because they're isolated by AWS accounts. It's very, very hard to break that isolation. And it's probably also a lot more secure than anything we can build. Also, the two endpoints of the system, actually it's three, but whatever, the IoT broker and the API, the REST API, right, to the web frontend, are both tenant specific. So they're for one customer only. It also means that everything has to be done as configuration as code, infrastructure as code. So CloudFormation in our case. Because there's just no other way you can manage 3,500 accounts. It just doesn't work. Everyone has to go through a CI. The ops team the VP at this point even took some work, but even he goes through that. Everything goes through CI because you just can't handle systems any other way at this scale anymore. But also, as I said, some downsides. We are limited in the number of services we can use from AWS. Something like EC2 would be forbiddingly expensive if we spin up even the smallest EC2 instance per customer account at this scale. So we don't. Couple of numbers, a bit of logic how this scales up. We have 3,500 AWS accounts. I already mentioned this multiple times. 39 microservices. Probably by the time this airs, it's 41. This change daily. About 70 million events. Also, that number keeps going up month over month, which is a very good thing. If you multiply that out, about 200 lambdas in each account, you get about 3,500 times 3,500 AWS accounts. You get somewhere north of 600,000 lambda functions, instances, whatever you want to call them. 200 source code things deployed 3,500 times get you that huge number. Obviously means the ops teams has a little bit of struggle here, but otherwise it just works. But I promised you a little bit of story about how this works on our deployment system. So one thing that should be fairly obvious, if I already deploy something for each customer, I'm also going to do the same for each developer, right? So each of our developers has their own AWS sandbox account. And you go in there, you get a blank AWS account, you open up your IDE, you type make install, or make all in this case, and it takes a little bit of time, but then you'll have your full customer system in there. And it's literally going to be the full system. Like there's not going to be a change between we call it the local system, which is very wrong because it runs in a cloud somewhere. But your local system, your developer system is going to be very, very close to the production system. It's going to have all the same services, all the same infrastructure. It's going to be the same thing. And then you develop your code, you do your changes, you test it out as much as you can. And then at some point you open up a PR. Once that happens, we actually spin up a completely separate environment again. Or the CI system obviously takes over in this case, and it just spins up a separate account. It takes it out of a vending machine, has a long list of accounts, deploys your changes plus everything else into that system and runs the full test suite on there. For every update you then do, it will run the whole suite again, all of the tests, make sure that everything will pass. Obviously then you get a code review and PR is updated, you work on it, and at some point in the near future, usually in a couple of days, days at most, usually hours, you get the PR merged and you merge it into mainline. In that case, the whole system starts again, merged into mainline. Another part of the CI system takes over and starts to deploy it through. This is what we call the production pipeline. We have currently one per pipeline, one per service, which is something we're looking to change. But there, basically, we deploy it to our integration stage. At this point, we already split it up onto multiple accounts, so not just a single one, but we deploy it on 5 different accounts to run all of the test stages in parallel, so we can speed up all of the rest of the process. And then, let all of the tests run again from, integration testing a single service to running load tests and more complicated E2E tests. Run all of these. Once all of these passes, and this is very, very likely, like we have very little pipeline breaks at that point, because it's the same as was running in the 2 earlier instances, and we already ran all of the tests we're running now in the stage before, so the difference is limited. Some of the E2E tests, some of the performance tests are only run on the integration stage, but it's minimal. And so we have very little pipeline breaks there, and then it just goes on automatically to production, where it'll go to all of those 3,500 accounts. This can take a little bit of time, but in general it's good. What does it do for us? Well, it makes multi-tenant development super easy. we don't realize it. Because we're working with the data in the account, in the database we have access to, and we don't need to worry about it at all. It also means that sometimes we get these messages. Hey, did you know we have this new customer that's putting in X amount of events, X amount of data? We didn't even know about it, even as the platform team running this whole infrastructure. We didn't know about it because there's no blast radius, there's little interference, and the system also scales extremely well thanks to the magic of serverless, which is awesome. So to sum it up, obviously, I'm not necessarily saying that you should replicate this. This works in our specific instance, in specific environment, but I think it's a very interesting approach to making development easy and also reproducible. Having a production environment that's the same as a development environment, giving you a really high natural security, because as a developer, it's really hard to break security on this system. Replication, obviously, environment replication is extremely easy. Also, it gives us a good amount of cost control because AWS accounts, again, very easy to cost control them, or relatively easy to cost control them. But there are also obviously some downsides. Observability and generally managing these accounts will be a lot more difficult than if you're managing a single account. You find out hidden quotas on AWS, interesting things. And also, as I said earlier, you have a limited service set. In the end, though, it's a very interesting approach to take and look at, and it really has some great benefits, both on the security side, which are very important for some of our customers, as well as on the development side, where it just makes it very easy to develop these kind of multi-account architectures. With that, thank you. Thanks for having me today, as I said earlier, and have a great day. Enjoy the rest.